presenting the stuff we are working on in France, in Montpellier, and it's a component-based programming language. So this stuff is not so serious in means of engineering like serialization or dynamic software updates. It's more general, it's abstract topic, and maybe the consequences are a bit wider. So that's why I named it Exile. It's because I felt like in exile working on it. Okay, so let's start with one. What we are doing, what is our motivation, is we would like to combine modeling and programming language. So you probably know some architecture description languages like Fractal or UML, where you can design your architecture of software and then you are looking for something to execute the model. And from the different direction, you write a very sophisticated software, and someone who wants to use it has to sometimes make a reverse engineering or something to understand the architecture of the software. So what we would like to do is to combine these two approaches into one language. And our approach is we would like to use component paradigm, and apply it into programming language. With such a language, we would like to design components, which we call design for use, and using these reusable components, we would like to design applications by connecting them. So they are, if you are wondering if there is a accepted definition of component, well, this one from Clemens University is broadly accepted by component guys. So you can read it somewhere. Okay, because you are all familiar with objects, I would like to explain what we felt is the difference between the object and the component. And the difference is for us that component as the object has some provided things, it provides some functionality with interface. But the difference in component is that components also express what it requires from the environment, and component has explicit architecture. That means one component can be made from another components, and they are connected. So that's the difference from object as we understand it. Exile is based on SCL, which is a component model designed by Fabrics. Thank you. And presented in Exil. And what we have done, we are trying to move it towards the modeling language. So I will give you some overview about SCL. In SCL, every component can be seen like a black box, which interacts with environment through the ports, which are described by interfaces. There are two roles, provided and required. The provided port is describing what the component offers to the environment. The required port describes what is demanded, what are the what do you need from the environment. So ports are unidirectional, that means the communication is only one direction, and they are somehow flags. Each component can have the services which are offered through ports, and they express the functionality of components. So they are kind of methods. And of course, port is described by interface. So interface is like the description of valid uses of a port. So let's go to Exile. We have same things as in XCL. So we have ports, we have services, we have interfaces. What's different? That, for example, example, we have reusable interfaces. That means we can design interface and use it more than one time. Ports are quite same. We have two roles, provided, required. We have connections, and we have what is the difference? Is that we have explicit architecture. That means we can define internal components and internal connections. So there is a component called compiler, which has internals parser and scanner, and they are somehow connected. So the architecture is covered by language. And another thing for modeling, we have implemented an inheritance. So one component can extend another component, and it inherits all the stuff. It inherits port structure, services, internal things. So it's very good for modeling. But of course, we do have problems with inheritance as they are in object-oriented programming and more. For example, if you imagine you have a person which has a heart and brain, and you would like to design a super overclocked brain which works faster if it has a coffee. Here you can see we have a brain, just some interface to control, some interface to access memory, and then we have designed an overclocked brain which it requires coffee and then it works well. But the problem is when we substitute the normal brain in person with overclocked brain, the additional requirement is unsatisfied. So the person does not have coffee. It's a problem, and I have an idea how to solve it, but it's too serious, and I will publish a paper soon, hopefully. So yeah, something about implementation. We are using the petit parser framework because we have a different syntax from Smalltalk, and our services are written in Smalltalk, so we are using of course petit Smalltalk parser for parsing the services. Compiler is designed by user pattern, and the core classes are Exil component and Exil interface. You can download the image in this website. I haven't published source code because I don't know how. I'm new in Faro, so if you can help me with that, I will be happy. So let's make a demo. Okay, I will make a demo about this component. This is an hello application which will say hello to us. And application consists of two internal components. One will produce the hello message, and it requires printer which will print it somewhere. So let's go to Smalltalk, and here I have some graphical user interface for Exil. So the main application is here. Provides one port called main, service hello, has two internals, hello and console printer, and they are connected by connection, and the initial service hello just call service say hello on internal see hello. So what does hello application component does? It will print a hello message on printer, and printer we have an abstract printer which just say the printer has to provide two services, print and clear, and then we have designed one printer which is console printer, which prints transcript, and another one which is graphic and prints morphic representation of this message. So it should be working. Okay, so we will create a new application on call service hello, and it prints us the message. And now I would like to show you the funny stuff with component-oriented languages. So let's imagine we would like to use the different printers, graphic printer. What we can do is change printer here, or we can design, with inheritance we can design a graphic application just by overriding the internal C printer with graphic printer. So the graphic application extends main application and it just overrides the printer. And what happened? I hope it will work. Yeah, you can see the message here. So the good thing, without deep knowledge about the system, I can make a change because architecture is explicit. And for example, I would like to reverse the string I'm sending. In main application, there is a string sent between hello and printer. So the stupid solution is to disconnect these two things. If we go back to picture, to disconnect those two and put here another component which will reverse the string and print it. Nothing easier with component languages. I will design another application which extends my original application. I will extend the graphic one, create a new reverse component internal, and change the architecture by disconnecting previous connection and creating new connections. And it should work. So let's see what happens. Yeah, it works. So as you can see, without deep knowledge about the software, I can modify it easily. It's quite interesting. Alright, so what are our future challenges? With this model, we are going to heavy stuff and following the consequences of the idea of having components instead of objects. And one of the challenges is to identify components in existing object-oriented systems. Like, for example, Alex has designed Mondrian and he does not know what are the components of the system. And it's very hard to identify it. We would like to have a reflexivity level to be able to write model analysis and transformation in Exil. Of course, architecture constraints, for example, you can say this internal can be connected only to another internals and constraints like this. And visual development. So here, where I have my graphical user interface, I would like to have rendered components and developed by visual things like working with UML diagrams and make connections. Not writing code. Yeah. So summary, Exil is a component-oriented language which merges modeling and programming capabilities, and I'm trying to bring component paradigm closer to Smalltalk users. compatible with Smalltalk objects, so we cannot use them. It's not like in your click where object is compatible with component somehow.
Can you give some guidelines on when should we use this component model? Like this evening, I'm going back to the hotel we program. And what are the benefits I can get by using Exil? How do we say Exil or Exil?
Exil, I prefer Exil. I don't know, it's a Czech pronunciation.
And Andrew, how do we say Exil or Exil?
Exile is with the E.
Exile.
Exile.
With an E, it's a different word.
Alright.
So this is not a word, so you can pronounce it however you like.
Alright, so can you give like some guidelines on when should I use Exil?
Well,
So what are the benefits? So what does it bring me?
it's hard to say, because as we are all familiar with object-oriented thinking, you probably cannot imagine easily the architecture of the software using the component paradigm. So if you think you can, your software, your solution is closer to components, so then you should use my language. But
Okay, so you mean that you're currently proposing a new way to program application instead of just putting something on top of as, you know, like, well, I don't know much about component programming, but like in Objective-C, then you can create a component, and then you can add some benefit from the operating system. I have a window, and I have like the file edit, view options, something like this. And why not like to have something like this? So why not like to use Exil to provide a kind of component model that instead of replacing the way people program, why not just put something on top of that can bring some.
You mean something like wrapping objects into components? You know, it's very hard to think about this problem because we are not used to use components in the all-the-day design.
What I think is saying that, for example, you can take the Smalltalk environment and say, okay, this class is a subclass from component, and if you implement the method services, you should ask the selector of the method defining services, and you can implement another method that says your requisite. So, for example, then you can build a tool or a language or whatever on top of that handles all of that. So if you subclass from component, then it's managed like a component, but at the same time I can have regular classes.
Yeah, I mean, the thing is like, if you take like OS X, like all the application looks like the same. The menu is very similar, but it's file, edit, view, and you have like the about, help, save, load, and you know, I think another application in Firewall, and all of them are different. There is absolutely nothing is homogeneous. And you know, and I think that there is an opportunity like, to have something to bring a bit of homogeneity and you know the shortcuts.
But you are speaking about having a framework, but the framework does not provide you with explicit dependencies as provided with components. And this is the added value of the component approach of based programming. So you have dependencies between entities in your application that are very explicit. So when you want to evolve your application to maintain it, then you see the dependencies, and you don't need to use some external tool to do some analysis to find out which are the dependencies.
Yeah, but I mean, like, understand. I think that in Microsoft as a component model, there is Apple was a component model, and I was just wondering, like, how
is something different?
This is probably is different, but these guys call that component model, and then they bring some clear properties such as having homologation. So I understand that.
This is the component paradigm in a language level. This is not in a like binary level.
I understand. But just.
So what I have to learn is to design an application in a component way. And it's very hard to think about designs. You know, try to the parser is a very good example because it contains a compiler, it contains two internals, and it's very easy to understand, but with Mondrian, I cannot imagine what are the components here. And
no, but if you see Glamour, in Glamour it spoke, Doro spoke a lot about components, but they are not explicit as we see in I mean, it is it's implicit. You are using some class and you are relying on some practices. You are constrained when developing.
So I suggest let's make this discussion in pub because that's always advancing components. I don't know why we are always arguing.